Assalamualaikum and hi, my name is FATIN BINTI ABDUL HAMID and the title of my final year project is Pollution and Risk Assessments of a Heavy Metal in Soil, a Review. Chapter 1, Introduction. Firstly, background of study. Increased population in the world has led in tremendous industrialization and urbanization, where this evolution have resulted in environmental pollution, which is including soil pollution. Therefore, heavy metal become a severe and global concern. Due to the rising urbanization and industrialization, an increasing amount of metal are discharged into the environment, and due to their non-biodegradability, heavy metal can persist in the environment, get into the food chain through plant, and then build up in the human body due to the biomagnification. This is the objective of this review. Chapter 2, Literature Review. Soil pollution. Soil is one of the most important elements for living alive, but however, according to the Food and Agricultural Organization of the United Nations (FAO), 1/3 of the world's soil is already degraded either severely or moderately, in which heavy metals and metalloids may accumulate in soil as a result of anthropogenic activities. Next, heavy metal. Heavy metal are widely distributed in the environment, creating issues and their possible impact on the human health and the environment, such as cadmium, lead, copper, and zinc. Heavy metal pollution can arise from many sources, but nowadays, most of heavy metals were introduced into the environment through natural or anthropogenic sources such as volcanic eruption, decaying vegetation, mining, industry, and agriculture. Chapter 3, Research Question. This is the 5th research question in this review. Chapter 4, Analysis and Interpretation. For the first analysis and interpretation, which is the comparison of heavy metal concentration in the soil, the concentrations of copper, cadmium, lead, and zinc in the soil from several areas in Malaysia and other countries were evaluated in this study. The table shows that the data of concentrations of heavy metal in soil obtained by the previous researchers in several locations. From the figure show that Southern Yunnan Province, China, recorded the highest copper with the value concentrations of 48.3 mgkg, while Liwa, Abu Dhabi, show a minimal value of copper in soil with 0.26 mgkg. This variation in this study could be associated with much ongoing anthropogenic influence due to the rapid urbanization, industrialization, and increased population in the area. Next, from the figure, it showed that the highest cadmium concentration is recorded by Bera, with the value 31.46 mgkg. The cadmium in Bera was found as highest concentration because the sampling were close to factory site. This indirectly indicates that the soil sample may have been contaminated with the metal deposition originated from the mill processing activities located nearby. As for lead concentration, Southern Yunnan Province recorded the highest concentration. The high concentration might occur as a result of rapid economic development with intensive industrial and agricultural activities. For zinc, the Panjijua, China is the highest concentration with the value 244 mgkg. The result indicate that industrial activity had great impact on heavy metal concentration and distribution. The table shows that concentrations of heavy metal in soil in several study areas were compared to the WHO standard guidelines. For copper, the concentrations of Panjijua and Southern Yunnan Province, China, had exceeded the guidelines set by WHO, while for Bera, Liwa, and Kuala Terengganu, each of them will comply with the guideline. Next, the concentrations of cadmium in 4 locations has surpassed the standard guidelines set by WHO, which are Bera, Pahang, Kuala Terengganu, Panjijua, China, and Liwa, Abu Dhabi. However, Southern Yunnan Province, China, complied the requirements set by WHO, which are 0.8 mgkg. Apart from that, the concentrations of heat in every study area were far below the requirements set by WHO. Lastly, for the zinc concentration, Panjijua and Southern Yunnan Province, China, would not comply with the WHO guideline, while Bera, Kuala Terengganu, and Liwa, all of them is comply with the guidelines. Factors that contribute to the different concentrations of heavy metal in soil, where diverse heavy metal are produced by garbage, landfills, burning fossil fuels, gasoline and gas emission from moving cars, agricultural and horticultural, as well as dangerous chemical used in the construction of infrastructures like buildings and roads. It is crucial to take in full account volcanic activity, toxic runoff and air quality as contributing factors to the occurrence and build-up of heavy metals in soil, which heavy metal has the greatest contamination rate in the urban soil today, depends on the type and profile of the soil, the area in which it is located and the climate and also demographic factors. In this review, 3 pollution indices, which are Index of Geoaccumulation, Pollution Load Index, and Pollution Ecological Risk Index, were used. The IGO of copper was compared between 4 areas and all the value was in the range of uncontaminated to moderately contaminated. Based on the Mueller scales, Kuala Terengganu is strongly contaminated by cadmium, while Panjijua and Southern Yunnan Province, China, are moderately or strongly contaminated, and Liwa is moderately contaminated. Next, the lead IGO are also in the range of uncontaminated to moderately contaminated. While for IGO class of zinc, Panjijua is recorded the highest value. This is clearly shown that the soil sample in the Panjijua, China is classified in the IGO class 3, which are moderately or strongly contaminated. From the study, the PLI range based on chrome, cadmium, plumber, and zinc of all the 5 locations follow the order: Pearl, Panjijua, Southern Yunnan Province, Kuala Terengganu, and also Liwa. Next, for the Peri value, Kuala Terengganu, Panjijua, Pearl, Southern Yunnan Province is classified as considerable level of potential ecological risk, while Liwa is moderately level of potential ecological level. Based on the study, most of the researchers use ICP-OES as their analysis instrument than ICP-MS. Even though ICP-MS has numbers of benefits, however, the cost and practicality makes ICP-OES overcome the ICP-MS because the ICP-OES is less expensive, more matrix tolerant, and generally easier to operate than ICP-MS. As a result, all of the objectives outlined in this review were successfully accomplished. The topic of heavy metal contamination in soil was explored in depth in order to discover its sources, concentration, and pollution assessment. Based on the study from the previous researchers, the highest concentration of heavy metal in soil is zinc compared to the concentrations of lead, copper, and cadmium. Therefore, as a recommendation for future researchers, more study on the concentrations of heavy metal in soil should be done in order to obtain more information on it, especially in Malaysia. Thank you.